Okay, so members, we have also different question here. Let us see how we go about it. But please don't forget to subscribe to the channel. When you subscribe to the channel, you are going to receive the notifications always. Okay, let us go through this question. Areas of two similar triangles are 18 square centimeters and 30 square centimeters respectively. If the base of the small triangle is 6, find the base of the larger triangle. Now, a base we know that is length, meaning to get the length, I need to be having the linear scale factor. And because they are giving me these two values here, you know that all I need to first get is the linear scale factor. So I can use the areas, these ones, to get the area scale factor. I know that if I have the area scale factor, I can get the linear scale factor. So the solution is area scale factor is equal to the big area over the small area, which will be the big area here is that it's 32 over 18. You can reduce by 2, and reduce by 2 is that our area scale factor. By 3 I have 16, by 3 I have 9. So I have now my area scale factor, but I know that area scale factor is equal to linear scale factor the whole square. So if I get this, now if I have this, I can get this. Now I start this is 16 over 9 is equal to this square. Take the square root both sides. You see that? If I take the square root both sides, so now my linear scale factor is going to be 4 over 3. When I take the square root of both sides. Now, if we know that linear scale factor is equal to the big length over the small length or the base. Now, they are telling us that if the base of the smaller triangle is 6, so we have this one, we want now to get this. So I have now 4 over 3 equal to the base I want over the base of the smaller triangle is 6. So this is 6. So that now if I cross multiply, 4 times 6 over 3 will be equal to b. By this one, by this 2. So that now my big base is going to be 4 times 2. Which would be 8 centimeters. Really is. So we are through with that. Then here, two similar figures have corresponding sides of length 5 centimeters and 10 centimeters respectively. If the area of the larger figure is 100 square centimeters, find the area of the smaller figure. Now here, all we need, we know that if we need the area, the relationship that relates the two is the area of the big over the area of the small. But area of the small, I need to be able to get the area scale factor, I can get using the linear scale factor. How is that possible? So the solution is, I know that area scale factor is equal to linear scale factor, the whole square. So how can I get the linear scale factor? So linear scale factor is same. Big length over the small length. Now our big length from there is that our big length is then over the small, which is 5. And so now our scale factor is equal to 2. We say they don't have units because these are ratios. Now my area scale factor is now LSF squared, which is going to be 2 squared, and this will be 4. If I have that now, you see that now I know that area scale factor is equal to the big area over the small area. Do you have the scale factor? Yes. Do you have the big area? Okay, let us go through. If the area of the larger figure, yes, we have the area of the larger figure, the bigger one, is 100 over the area of the smaller figure, which we want. If I cross multiply, is that For A, will be equal to 100, and set by A is going to be 25. Now this is going to be, because this is area, therefore, area of the smaller figure is 25 centimeters squared. So that's it, members. I wish you the best.